So the original goal of this project was to leverage the kind of know-how that we have in material science and engineering to create tools that would enable the biology community and especially the plant science community to explore questions regarding the collective effects that can occur in communities of plants. So in a sense, we saw an opportunity to develop tools to create model ecosystems with which we could start exploring quantitatively to what degree plants interact with each other and to what degree plants interact with their own environment more at large. Typically in soil, when plants interact with each other or with other organisms like microorganisms, bacteria and so forth, and fungi, these interactions takes place at very short distances, the order of millimeters. And that's because this signaling, this exchange of information between organisms is associated with molecules, with the exchange of signaling molecules. So effectively, the language that the organisms are speaking to each other is in the forms of molecules. And the molecules can only move so fast that the movement is largely limited by a process called diffusion in soil. And that process is very, very slow. This is why organisms need to be very, very close together. This is a very severe limitation actually from an experimental point of view, because you cannot, once you've mixed everything together, you cannot control the rate at which these molecules are being exchanged. And so what we had to come up with was a way to create a completely new way of developing these model ecosystems in which effectively each organism would have its own environment, its own habitat, and then we would connect these habitats in a fluidic circuit. And then by using a process that is known in chemical engineering as dispersion, we were able to accelerate this process of diffusion fast enough that even though these habitats are separated by centimeters, the organisms are still able to communicate with each other. So we started playing with this idea of using Legos as the first step in building these habitats that would be modular, scalable to different plant sizes, and easily modifiable. So you can take your habitats apart and reassemble them in a different way to run a different experiment. My students are essential. They are the ones that really do the work. They are very highly motivated.
Hi, my name is Souvik Banerjee. I am a third-year PhD student in Material Science and Engineering Department.
My name is Oskar Szymanowski. I'm a postdoc in Ludovico labs. I'm PhD in plant biology and plant physiologist and exercise in molecular genetics.
Hi, I'm Kara Lind. I'm a fifth-year PhD student with Ludovico, studying material science and engineering.
Hi, my name is Michao Xi. I'm a postdoc research associate in our group. I got my PhD degree from University of Chinese Academy of Sciences.
I'm Lin Ma. I'm the third-year PhD here and also the research assistant.
We are now able to connect these habitats together to create model ecosystems in which we have complete control over what chemicals are being exchanged and what is the specific environment of each organism. So it's essentially, we have gone from using Legos to create habitats for single organisms to actually creating a Lego of organisms where you can actually plug and play different organisms in an ecosystem to start looking at collective effects in these collective groups of organisms. Dr. Arnold O'Backman was very keen on empowering the scientific community to do new experiments and to pursue new questions. And I think that's what we're trying to do in our laboratory. Dr. Arnold O'Backman's contributions to science, technology and education have been wondrous. His approach to the scientific pursuit married the romantic and idealistic with the pragmatic and useful. It married daring with rigor, excellence with playfulness, And it is from this masterful balance that the legacy of Dr. Arnold Beckman has become one of tremendous tangible resources that have provided life-changing opportunities to young scientists across the nation, and one of wisdom and inspiration that will always provide young scientists with a vision of what scientific research can be and can achieve. The work of Dr. Arnold Beckman has reminded me of the value of thinking outside the boundaries created by definition, fields, and jargon, as well as the value of simple solutions to practical problems. I am very grateful to the Arnold and Mabel Beckman Foundation for the unique opportunity to pursue a highly exploratory and ambitious project at the boundary between plant science and engineering.